Hey everyone, 2012 question 3. This is a graph analysis problem, okay? So here we go. Right away, I noticed that the graph represents f, and then they give me a g function, which is the integral of f from 1 to some number, okay? So here we go. Part A, very straightforward. They ask you to find g of 2 and g of negative 2. So pretty much what we're going to do is we're going to individually plug in 2 into x and negative 2 into x. So separately. Now, what you want to know is, what does it mean? So g of 2 is really just the integral of f from 1 to 2. Okay? And g of negative 2 is the integral from 1 to negative 2 there. So you do have to remember that that just means we're finding the area. Okay? So for g of 2, we're finding the area from 1 to 2. So pretty much here. So if you notice, that's a conveniently shaped triangle, okay? A right triangle, so we know the area is going to be 1/2 base times the height. Since the area is actually below the x-axis, right away I'm going to put in a little negative right there so that I don't forget. The base is just 1. Now the height, people tend to get a little bit confused, but remember, notice how it lines up on a line here. I noticed that at 1, the y value is 0. At 3, the y value is at negative 1. So if you just use some logic right in between there, from 0 to negative 1, it's just 1/2. Okay? I don't need to put the negative because it's just the distance. All right? So the area there comes out to whatever it is. I don't care because equal is equal. Okay? But notice how it does match up right there in the scoring guidelines, okay? Now, from g of negative 2, notice how the bounds are a little bit backwards. So you could actually flip it around now so that you could reverse the two bounds there, okay? I would encourage you guys to do that. It's really difficult reading from right to left. So here we go. So from negative 2 all the way to 1. I'm going to shade it in here in purple. So from negative 2 all the way to 1, I get everything in purple right there. This right here is a triangle, so 1/2. I know it's going to be positive. Base times height. The base there is just 1. The height is just 3 because that's the y coordinate. That comes out to 3/2. But it doesn't matter. Equal is equal. The second region here is a semicircle. Notice how it's below. So it's going to be negative pi r squared over 2. Because that's the area of a semicircle. Now the radius is really just 1. Let me undo that. The radius is really just 1 here, so from 0 on outwards, or in any direction, that's really just a distance of 1. Okay, so if you just combine these two here, that should give you your answer. Equal is equal. They actually did try to clean it up a little bit more. So what I would do is I would write negative for the fixing of the bounds. Okay. Area of a triangle, which is positive 1/2 times 1 times 3. And then I'm going to subtract pi 1 squared over 2. I'm subtracting it because the area is below the x-axis, okay? That's enough for you to just leave it there. That'll give you two quick points there. Let's move on to part B. Part B, they start introducing g prime and g double prime, okay? So if you guys know that g of x is the integral of f from 1 to x, then g prime, you would have to take the derivative of that integral, which is just f of x. When you integrate a derivative, or if you take the derivative of an integral, you just get the function, okay? If we actually go one more time to the second derivative of g, then that would just be the derivative of f. In this case, we would just write f prime of x there. So they're asking us for two things, g prime of -3 and g double prime of -3. You're pretty much plugging it in. So let me just jump straight to that there. G prime of -3 is really just f of -3. F of -3 is really just a location, a point. If you're looking at your graph at -3, when x is -3, which is right here, that y value is just 2. I know it's 2. Sorry, -1, -2, -3. Because the y value right here is 1, and that y value up here is 3, so halfway definitely has to be 2. Okay? So there is some analysis involved, but not that bad. Now, if you go to g double prime of -3 is really just f prime of -3. Now think derivative, right? Derivative just means slope. So at -3, they're pretty much just asking you, what is the slope of this line? You could do two things. You could do the average rate of change between these 2 points right here. You could do 3 minus 1 over -2 minus -4 and get your answer. Or you could actually just do rise over run. I rise 1, I run 1. Or you could even do I rise 2, I run 2. It doesn't matter, but your slope should come out to 1, positive. We know it's positive because the line is going upwards, okay? So you actually do have options there. But again, those are two easy points to obtain as well, okay? Part C. Find the x-coordinate of each point at which the graph of G has a horizontal tangent line. Horizontal tangent line. That is code for when G prime is 0. Because if G has a horizontal tangent line, tangent means derivative, horizontal means the slope is 0, so G prime has to be 0 here, okay? So here we go. G prime of x is equal to f of x, so we know that we can set that equal to 0. So pretty much, where is f of x 0? Look at that graph there, okay? There's a lot going on, so let me erase it. F of x is 0 at two different moments. At 1 and at -1, because this is where it touches the x-axis. Now then they ask you, for each of these points, determine whether G has a relative min, max, or neither. Okay, so if you notice, the graph of f changes from positive values to negative values. So we know that has to be a local max, okay? Now at 1 here, the values went from negative to more negative. Since there is no sign change, we would get neither there. So they basically wrote it in words. You could definitely simplify it. I would definitely say, at x equals -1, G has a local max. Since G prime goes from positive to negative at x equals -1. Okay, however you want to write it, but definitely avoid the words like it. Okay, especially for this problem because there's so much going on. There you have it, okay? Part D. Find all values of x for which the graph of G has a point of inflection. So right away, buzzword is point of inflection. Right away, I'm thinking where G prime changes signs. Okay, so what you want to do is what do we know about our second derivative? Okay, we know that G double prime is equal to f of x here. Okay, so we want to go ahead and set that equal to 0. G double prime of x, which is f prime of x, is equal to 0. So what we want to do is we want to see where f prime is 0. So remember that f prime is referring to slope. Okay? If you go back to your graph, where do your slopes change? Okay? So let me erase this here. Now we're analyzing the slopes, okay? So right here, the slope of f, or you guys just call it f prime, starts off positive because the graph is going upwards. Then the graph goes from positive to negative slopes. And it goes all the way until we hit about 0, okay? It's all negative. It's all going downwards. Then f prime goes from positive and then to negative again. So how often did it switch signs? It switches signs right at -2, at 0, and at 1. And you would just have to explain that. I would just say at x equals -2, 0, and 1, since f prime changes signs. And that's it.